Hello and welcome everyone. Today I'm presenting a session on how to leverage Windows Azure for performance testing. I'm sure if you're here today, the interest is either in Windows Azure or with performance testing, and if both, then that's great for all of us. My name is Tarun Arora. I'm a Microsoft MVP in Visual Studio ALM. For the past several years, I've been working with various clients in the industry to help them optimize and enhance their ALM capabilities. Nowadays, I'm having great fun playing around with Dev12 and GitHub. And if you too, like me, think GitHub is cool and is probably the next big thing, then let's catch up outside the presentation, and I'm sure we'll have a great discussion. So what's on the menu card for today? Today, I'm not going to try and solve all your problems. Today, the motivation and the drive behind the presentation is to stimulate you enough to go back and start exploring the possibilities of harnessing the power of cloud for testing your applications. So this presentation should act as a spark for you to go back and start looking for practical opportunities, maybe within your projects or at your client side or within the organization as such, or maybe in your after-work test projects to see if you can make use of this technology somewhere. So I'm going to start with why the conventional testing tools and practices don't work in today's agile-driven dev and test process. You know, nowadays we're not very waterfall, so our entire sprint duration is not more than 3 weeks. And if we start following the conventional approach, certain processes just tend to fail, which become a bottleneck for performance testing application in the SDLC. Once we have covered the why, I will move on to how, wherein I will discuss with you how by leveraging Windows Azure we can address the loopholes in the conventional practices and allow you as a tester to be as responsive to the ever-changing applications as you're testing. By then, I hope to have you stimulated enough to ask all the right questions. Questions around the cost model, bring up any concerns that you may have, concerns such as data security, IP spoofing, and as you start thinking, we can start discussing some of the practical scenarios as well. And in the end, I'm going to show you a little technique to auto-generate the web performance tests and start hitting the sweet spot with the first test execution that you perform. So let's get started with a few industry facts first. So there have been several studies conducted by leading players in the industry, which indicate that an increase of just about 500 milliseconds in the page load time can result in a drop of about 20% in the traffic. Now, it shouldn't come to you as a surprise because at times when we as developers are looking to solve a problem, we start using Google or Bing and start searching and surfing the web with our queries. And we tend to get a lot of responses in return, and we would open a couple of pages. But when the page takes more than a certain amount of time to render, we just abscond the page. We just leave it and move on because it's taking too long. And there's so much competition at the moment that if your page is not quick, it's probably not going to be there for much longer. And this is one of the reasons why site speed is included as one of the metrics in the search ranking algorithms for the leading search providers nowadays. An interesting study that has been conducted by Amazon indicated that for 100 millisecond increase in the page load time, Amazon started losing 1% of their revenue every day. And for a company of the size of Amazon, if you crunch the numbers, this figure comes to around $900,000 per day, which is a lot of money. So that's why they rightly say that, you know, you haven't tested till you have performance tested. And I can't emphasize enough how important performance testing is to the overall software development lifecycle. So why is that performance testing doesn't get the same level of attention as it should? I'm sure a lot of us have performance tested within our projects or have been involved in some sort of performance testing phase in our careers. And I'm sure that the phrases I'm going to read out next would not sound very alien to you. So you go after the infrastructure team, telling them that you're in the middle of performance testing and you require some additional hardware. And you're told off. You're told, come back after 3 weeks. Procuring additional hardware takes minimum of 3 weeks. You should have planned better. Or you could have your project manager come over and say, we're close to burning all our budget. Is it not possible that we just performance test with a user load of 10,000 users and forecast the system performance for 50,000 users? Or this one's really common, that you would get an email from your infrastructure team telling you that they would like to take down these servers because the servers need to be patched. The server patching is essential before the audit next week, so you will have to stop your testing. So you'd probably agree with me that the problem is not with the tooling, but the problem is with the high administration overhead and the infrastructure cost that comes with this phase of testing. Because you have to rely on someone else to set up the system, set up the infrastructure, you need to plan well in advance. And this doesn't necessarily go down too well in today's agile-driven development practices. Also, what do you do with the performance testing hardware once the performance testing phase is over? Now imagine if you're threshold testing a production server, which is a multi-core beefy server, then your performance testing server needs to be, if not more, equally powerful. But what happens after the performance testing phase is over? What do you do with that hardware? You still have to take care of the administration cost that comes with managing and maintaining that server after the performance testing phase is over. So you don't really get to utilize the hardware to full potential. And this is a drawback. Also, most importantly, the tools for performance testing aren't cheap either. They're not a natural extension of your developer tools, so you have to go off and buy special tools for testing, and then special tools need specialists to operate them, which is more cost, and then you probably need additional licenses to set up those test servers, and on and on and on. Another thing is that if only there was a scalable, a flexible, and an affordable solution available in the market, then this problem could be solved. And there certainly is a solution available in the market if you bring Visual Studio and Windows Azure into the equation. Now, Windows Azure, as you probably are aware, gives you the elasticity to scale up and scale down your servers based on your test requirements. Moreover, you're not responsible for managing the environment. Microsoft takes full ownership and responsibility of patching the servers, doing the environment management. And you're, on the back of that, guaranteed a 99.95% service uptime, which in today's world is tremendously good. Now, Azure naturally seems like an extension of your MS Test toolkit as well. You're only charged for the usage, which is minimal if you compare that with the upfront cost of the current process, where you have to go off and buy servers, which incurs a tremendous upfront cost. The licensing does not limit you to a constrained user load. You could go off and generate an unlimited user load if you wanted to. I'll be discussing the costing model in much more detail as we move forward in the presentation. Also wanted to mention here that apart from the quick wins that Windows Azure offers, there are additional testing scenarios which you can test now, which was practically not possible to do in the conventional world. And the first one is being able to test globally. Now, what do I mean when I say being able to test globally? Now, imagine if the web server is hosted in location A, and the user accessing that web server where the website is hosted is also located in location A. So both the user as well as the web server are in the same location, probably connected via LAN. So when you open the browser and you type the name of your website, it takes less than a split second for the communication to travel from the user to the web server, and from the web server back to the user, which means the actual time is only spent for the web server to process your query and not in the actual to and fro. But what if the user is taken away from location A and is not on the LAN anymore and tries to access the same website from around the world in location B. Now when user A from location B tries to access the website, his request first has to travel from there to the web server, and then from the web server it has to be processed, and then it has to travel back. So the processing time remains the same, but an additional time of the request traveling from one direction to the other is something gets added on. Now I'll give you a practical application here. You know, we worked with a client where we had to implement a SharePoint-based intranet system, and they had offices in Houston, they had offices in Singapore, and they had offices in London as well. The web server was hosted in London, and they demanded that as a non-functional requirement, they would like the web page, intranet web page, to render in less than 2 seconds, and that users from across the world should have the consistent experience of accessing that web page. But in the first test, we realized that that user running the application from Houston was only able to see the page at 6 seconds. And the actual processing time of the page was just 30 milliseconds, which means that the rest of the time was consumed in the connectivity, sending the request over and receiving the response back. But how do you practically test that? How do you emulate the network differences? How do you test globally? With Windows Azure, it's very easy. You can harness the possibility of Windows Azure servers for being available across the globe. If you set up one of your test machines in the US, the other test machine in Europe, maybe the other one in the other test servers, and generate the user load from these servers from the different continents they're placed in, you're practically emulating the network or the global testing or the global traffic that your website will see. And then you can work out from which places the website slow and try and address this with probably by creating a web farm or by synchronizing your content across the world and so on and so forth. The practical scenario, another practical scenario that you'll probably be able to test with Windows Azure is you aren't bound with the amount of compute power you can consume with Windows Azure, and there is no upper limit with the number of user loads you can generate. So potentially you can test an application with unlimited user load. Now, if you're planning to build the next Facebook or the next LinkedIn, then you definitely need to keep scalability in mind, and you definitely need to be able to test for a large user load, and this certainly makes this possible. And the next and the most important thing, in my opinion, is the return on investment. Now, why I say that is using Windows Azure and Visual Studio, you don't need to invest in any other tools or licenses. You know, you're not charged for setting up X number or Y number of test controllers and agents. So basically, because you're making use of your existing investments further to be able to performance test and load test and report your statistics back, you're using the same IDE. That means you're getting more investment returns on the investment that you've already made, which in my opinion is very important. Now that we have covered why the current approach fails and sort of where's the opportunity for Windows Azure to step in and kind of balance the loopholes out, we will move on to how we can leverage Windows Azure in all its practicality to cover the scenarios and further move on to the demo. But before that, I'll just quickly explain what a test rig is, because this is a term I will continue to use in the rest of the presentation. Now, test rig is one test controller plus one or more test agents. Test controller comprises of a machine which has the Microsoft Test Controller software installed on it, and test agent is a machine which has the Microsoft Test Agent software installed on it. And a test rig is a test controller plus an n number of test agents. Now, test control is more like a project manager. It will orchestrate the test execution. It will shout out to the test agent saying, you need to execute this test. If you're free, you need to do this, you need to do that. On the other side, the test agent does the heavy lifting of actually simulating the user load, executing the test, and once the test is executed, feeding the results back to the test controller, and the test controller internally storing the results on a SQL database. Now the SQL database can be stored on the test controller machine itself, or it can be stored outside the test control machine. It's important that I highlight that the best practice says that the test controller database should be outside the test controller machine. That's because you do not want to add more you don't want to take away more of the processing power, because the test controller is already testing something, and by further processing to store the results in SQL, that might deviate your actual test results. So now that we understand what a test rig is, how can we set up a test rig? Now there's the conventional way, which is let's set up the entire test rig on premise. Your test controller, your test agents are on the same VM, or they're on separate VMs, and everything is on premise and you continue to test. The more modern approach is leveraging the power of the cloud. So we have the option of setting up a mixed model, a cloud-based model, or bringing both together to set up a hybrid model. Let's first discuss the mixed model. And as the name sort of suggests, the mixed model is the one where we're using the capability of on-premise and bringing the goodness of the cloud and putting them together. So the test controller is set up on-premise, so is the test controller database, and the test agents are practically what we need more and more machines for simulating the user load, are stored in the cloud. The communication between the two is allowed or is enabled using the Windows Azure endpoints. Now this approach tends to work best for companies where we're testing intranet-based software. For instance, an intranet website or some of your business critical applications hosted on your web servers within the closed spheres of your organization. The next model is known as the cloud-based model. Cloud-based model is sort of a more modern model where your websites are stored in the cloud, and so is your test rig. And this approach, in terms of cost, works out best for organizations where the website is hosted in the cloud. And by hosting the test rig in the cloud as well, you aren't practically leaving the data center. Now, if you know Windows Azure and you know the costing model, you'd agree with me that every time you leave the data center and come out of the data center, you incur a cost. Inbound traffic to the data center does not incur a cost. So if you're hosting the website and you're hosting the test rig within the same data center in the cloud, there's practically no cost, and you can test as much a user load as you'd like, or as much as practical for your website. Again, the communication between the test rig and the machine on-premise triggering the test is enabled using the Windows Azure endpoint. The third and the more modern approach is a mixture of both the cloud as well as the mixed setup model, wherein we have different test rigs to test the various scenarios. For instance, nowadays companies are investing in building some of the components of their website in the cloud or hosting them in the cloud, and some of the parts of the application being hosted on-premise. To be able to test such a scenario, you need your test rig to be more hybrid. So some of the test rigs are stored up in the cloud, some on-premise, some are a mixture. But as someone who's governing that model will say, how do I report now because I'm running so many different test rigs? Well, here you can make use of Windows Azure Sync to pull the data, which is the test result from all these different test rigs, and pulling them into a single SQL Azure database. The biggest advantage with this approach is, now SQL Azure storage is cheap. It is, we all know that the storage in the cloud is fairly cheap, and by storing all the results in one central repository, you can actually build a timeline for your applications to show that the application performance has increased over the span of time, or it's decreased over the span of time. And if you fall in the second category, your management is not going to be very happy with you. Okay, enough talking. I will move off to the demo now. In the demo, I plan to show you how we can use the second setup model, which is the cloud-based model, to sort of test an application or test a website which has been built using the agile practices. First, I need a Windows Azure subscription. If you don't have one using MSDN, then you can always opt in for one by registering for the free subscription. It's 90 days free subscription without any cost liability. So you're safe to enroll for that. The second part is I need a Visual Studio Ultimate. If you weren't aware, it is only in Visual Studio Ultimate that you are able to, you get the web performance testing and the load testing features. These features are not available in any of the other Visual Studio SKUs. I need the test controller software and I need the test agent software. The test controller software will be installed on the test controller. The test agent software will be installed on the test agent. And I'll be building a Windows Azure project using the Windows Azure 1.6 SDK. Now, before I jump into the demo, I'll briefly give you the logical setup for my test rig. First, what I will do is I know that the test controller, the test agent, and the SQL Express are three softwares that I need to be installed on my worker roles that are set up in the cloud. So what I will do is pre-hand upload these softwares onto Windows Azure Blob Storage. Now, I don't have to do this. I'm doing this because going forward, I will save time. It is only a one-time effort which takes about 20 minutes to upload these softwares on the Blob Storage. Because there is no cost of incoming traffic to the data center, you could actually every time download these softwares from the website and install them. But by putting them in the blob storage, I'm eliminating that extra 15-20 minutes in the future that it will take me to download that software. So that's step one. Step two is I will put together a Windows Azure project solution. This magical solution automates the entire deployment process for the worker roles, the installation of the software. When I click publish, it spins up a new test controller in the cloud. It goes off to the Windows Azure Blob Storage, downloads the test controller software, downloads the SQL Server software, and starts installing that on the new worker role. Once the installation completes, it starts to create the test agent. It does the same thing, goes off to the blob storage, downloads the test agent software, installs it. At this point, the Windows Azure endpoints are enabled. And once this is enabled, then the test agent goes off and registers itself with the test controller. And when this scenario or this setup is complete, we can officially say that the test rig has completed. Now, if we start talking about the time it would take, so there's a one-time effort of uploading the software to the blob storage, which takes about 20-25 minutes. The deployment of the test controller and the test agents takes about 20 minutes, and then after we enable the Windows Azure endpoint, there is a 10-minute refresh. So first time it would take you 40-45 minutes to set up your test rig, and after that it would take you just 25 minutes. So you know, look at that, 25 minutes to set up your test rig versus someone telling you you need 3 weeks to tell them that you need a test rig so that they can procure the hardware, set it up with all the policies, and then blah, blah, blah before they hand it over to you. So, you know, you can start doing a comparison and see the benefits of going down with the Azure route. Great. So I will move on to the actual demo. Bear with me while I pull out the softwares that I need. Okay, just a second. Okay, on your screen now, you should be able to see the Cloud Storage Studio. This is a software which is currently owned by Redgate. It's used to manage the blob storage in the cloud. You know, if I have to upload the software on the blobs up in the cloud, I need a way to do it, right? One way is I could go to the search engine and type and look for free blob storage softwares, and there are plenty of community projects out there on CodeFlex and SourceForge, which are free to download, and they work very well, allowing you to upload anything on the blob storage, delete it or zip it or kind of archive it and download it back if you need to. This one is good because it's supported by Redgate, and being an MVP, I get a free subscription for this as well. Okay, so once you open this for the first time, you'd require to set up your subscription. And as I said, if you have a subscription to MSDN already, that's great. If not, then go off, register for the free subscription. Once you get the subscription and you add your subscription, you would see a node like this. Further expand this and drill down for storage accounts. Now, storage in the cloud means tables, queues, blob containers. I will be making use of the blob. So what I do is right-click the blob container and say, let's put together a new blob container. I call it Kolkata Geeks Demo. I have to make this public. Click Save. Okay. Now, I get this cool window where all I have to do is go off and search for the software that I need to upload. In my case, it's just these three. Drag and drop here, and click Start Upload. So for the benefit of the demo, I've already performed this step, but as you have already seen, it's fairly simple. Once the software is uploaded after 20 minutes, it's just a demo. At times you expect things to crop up quicker, but they take more time in the demo. Anyways, yeah, once the software is uploaded, it looks like this. And I should be able to click on the software that's been uploaded and choose View Blob Properties. And what I see is this blob property shows me that this is the direct link or the direct URL for this piece of software up in the cloud. So if I had the connection string for my blob container and I had this URL, I can download this software on the fly at any point of time, right? So I'm going to take note of this, take note of the next URL, and take note of the next URL. So my work with the blob storage manager is done. I've uploaded the software up in the cloud. I have a direct URL for them. Now I will take you to my Visual Studio solution here. So I have this team project which has an automation solution for both Visual Studio 2010 test rig and Visual Studio 2012 test rig. Today I'll be demonstrating the Visual Studio 2012 test rig, but if you're interested to try this out yourself, drop me an email and I'd be more than happy to add your Windows Live ID to my TFS preview account, and then you can download the solution yourself and play around with it. So once I open the solution, I've got a Windows Azure project here. I've got a couple of C# library projects here. So let's expand the Azure load test. You can see that I have two roles. Within the Azure trajectory, you can either create a worker role, a VM role, or a web role. And in our condition, the worker role will suit us the best. So I create one worker role for agent and one worker role for controller. Further, I've got a service configuration file and a service definition file. Service definition files keeps all the information that is utilized when we're publishing the project. So let's have a quick look at the controller. Now in the controller project, all I'm saying is set up one small instance of the test controller. And on the settings page, you can see I've got this set of settings. Let's look at the first one, which is I'm specifying the connection string of my blob container. Now take note of this. I will be showing you how I can get the connection string from the Windows Azure Management Portal slightly later in the presentation. But this connection string is required. And after that, I'm keying in the URL of where the SQL Express has been uploaded in the blob storage. And similarly, keying in the URL of the test controller. Apart from that, this is the key or the Windows Azure Endpoint authentication code to enable Windows Azure Endpoint on the test controller. Now what's important to note here is that the test controller, the test agent, and the machine on premise need to share the same code to be enabled to communicate amongst each other. Now this code is generated in the management portal, which I'll show you slightly later in the presentation. The next important thing to note is that I'm creating a local user on the machine by the name of admin. Now this user will be required for two purposes. The first purpose is when I spin up the worker role and in case the deployment fails for some reason, by enabling the RDP session, I can always RDP onto the box later with this username and see what failed. I can go off, look at the IntelliTrace logs or look at the deployment logs and maybe fix the issue myself. The second reason is I need this username set up on both the test controller, the test agent, and my local machine in order to run this test rig. This I will be highlighting later in the presentation as well. Apart from that, in the endpoints, I've set up some port exceptions to say, this is the private port, I need a port for SMB, NetBIOS. And apart from that, for local storage, I've said, when you create the test controller in the cloud, create a folder for test controller _ bin, SQL Express bin, and SQL Express data, and give them this many MB or size, the folder size. Let's look at the agent worker role. The agent worker role, I'm saying create me 2 small instances of test agents. You can start with 2, but as you start testing more, you can scale on demand. You could change this to 10, 20, 30, 40 to suit whatever test you're running. Apart from that, similar settings, I'm specifying the blob container connection string. I'm specifying the URL for the test agent. I'm specifying the Windows Azure endpoint authentication code, and I'm creating a user by the name of admin. Right? Fairly simple, fairly straightforward. Now, where does the fun part come? The fun part comes over here. Now, what I've done is I've scripted the test controller setup. So I say, when the Windows Azure worker role is being deployed, then as a startup command, go off to the blob storage, download the software for test controller, unzip that software, and then do an installation. This is a quiet installation, an unattended installation. Same I've done for SQL Express. So no user intervention required, simply install yourself. And same I've done for test agent. And once this step is performed, it keeps checking whether this is installed. And if it's installed, it goes off and configures itself as well. Again, unattended, no user intervention required. Great. So once you reach that point, you right-click and you click Publish. First time when you come to the screen, you would get this page in the wizard. You'd be required to associate your Windows Azure subscription with this, because it's only using your Windows Azure subscription that it can go off and create the worker roles. So press Next. Now this is what I'm calling my hosted service. It's a demo. I can choose to deploy in production, or I can choose to deploy in staging. I can choose which release configuration I want to associate with this publishing. In the advanced settings, I would encourage you to enable the IntelliTrace so that in case anything fails, you can always come back and see what failed. And also enable remote desktop. Now press Next and click Publish. Now, keeping the interest of time, I have already published this software. Once the publishing completes, I'll show you in the Windows Azure portal what it looks like. So when you log on to your Windows Azure portal, and the deployment has completed, you will see this screen. Click through here and see my controller has been deployed and my agents have been deployed as well. One controller, small instance, and 2 small instances of the agents. Now, all I have to do from this point is go to my virtual network, choose my subscription. From this screen, I can see all the machines that have the Windows Azure endpoint enabled. And remember, I mentioned that you have to get the activation code. This is the same activation code that all the machines in the background are sharing. Now, all I have to do is set up a group. I've created a load test group. In the load test group, I've added all the agents and all the controllers I would like to use in my test rig. And when I've completed this, I've completed my test rig setup. So I will hover over to my VM where I have Visual Studio 2012 installed. Just give me a second. Okay, so I'm in my VM now where Visual Studio 2012 is installed. I'll bring this up. Now, what I plan to demo you here is a quick creating a web performance test and then converting that web performance test to a load test and using the test rig we have set up in the cloud to run that test for me. So for the purposes of demo, I will be using a website which is hosted in the cloud. I'll quickly show you what the website looks like. The website is an event website which shows an event that the company is hosting. It gives users the option to find out who's sponsoring the event. They can get in touch with the organizers, and if the employee logs in, he can then register for the presentation and enroll for the presentation, choose what sessions the user would like to attend, so on and so forth. So, a simple website, good for performance testing. So let's carry out Okay. So step one, we have to create a test project. So file, new project. I'm choosing Visual C# and I come down to test. I can see a new project type that has been added, which is web performance and load test project. Let's name this Kolkata Geeks Web Performance Test Project. Yeah, press OK. So this internally creates the project. Just takes a couple of seconds. Great, I can see the project being created. Now the project here creates this default web test. I'm going to delete this to show you where I can add this from in case I need to. Delete it, right-click the project, and select Add, and click New Web Performance Test. So this gives me a new web performance test. This gives me the web performance test recorder. All I have to do is paste the URL that I'd like to test, or type the URL that I'd like to test, and click Enter. At this point, whatever request and response takes place between the web server and the client is recorded. So all the HTTP traffic is recorded here. So I'm saying click on home. So an average user, when they come to the website, will probably click on home, click on sponsor, click on contact, maybe try and register themselves. And you register themselves, and maybe they would say they've used the website and they close the website. So when I press stop, all those HTTP requests and responses are taken from the browser, and Visual Studio starts to analyze them. And what it does internally is create a web performance test. What it's doing at the moment is detecting if there are any dynamic parameters in the request and the response, like session ID or any other cryptic dynamic parameters that might have been passed. So once it's done its processing, it completes the test and creates a web test for me in the background. I can see that the test has passed. So let's just quickly look at what it did. I can see the request, the response, the clicks. So fairly simple test, nothing complicated. But it's very interesting to know that if the same website now was accessed not by one user, but maybe by 2,000 users, how would the website fare, right? And this is very important. Imagine you as a developer create a website for Kolkata Geeks, and you test it as one person, and the website you see might go viral, and so many people want to access Kolkata Geeks website. So you have to load test the website before you launch it to the bigger audience. So what you do is you right click and choose Add and choose a load test. Click Next and say you would like to viral load test. Yeah. Now you have the option of keeping the think time between the web request and response, or removing them completely. The purpose of keeping them is creating a more natural scenario, because when a user comes to your website, they will click a button, they will wait for a while, and then they'll click the other button. It's not going to happen that they'll come, click, 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 and go away. So it's good to keep a normal think time between the request and the response. Press next. You have an option to specify the user load. You could opt for a flat user load of 25 users, or you could say that I want to start with 1 user or 10 users, and then after 10 seconds, add another 20 users till you reach a maximum user load of 20,000 users. Right? And this is the more natural scenario. If yours is a company where the marketing guys go out and do a sort of marketing act, and they expect more users to visit your website, it's not going to be in one day that all the users come down and access your website. It will be more of a sequential thing where slightly more users and then slightly more users. So we're testing a step load here. We move on to the next page. Because I only have web test, I wouldn't be able to explain this much to you, but you can choose between how you would like the users to test the various tests you have in the load test. Press next, and I can add my test here. So this is the test. Click OK. I only have one test, so press next. I can try and test for various types. I can test the LAN. What if the user is using a dial-up connection, or what if the user is using a DSL, and so on and so forth. Go to the next screen and you can test what browser your user is using. Whether you can simulate the HTTP request and the response headers for different browsers. Press the next screen. You can add the controller, the agent, or the web server, or the database server from where you would like to import all the logs, the event logs, the IntelliTrace logs, or the ASP.NET profiling. Press next, and you can choose the test duration. Now, for our test demo, I'll just run a 10-minute load test session. But if you think of it this way, organizations that are doing load testing are further distinguishing it in different buckets. The first bucket is, let's see how much load can our server tolerate. That is more of a threshold testing. So you would change the run duration to, let's say, an hour and try and set up a step load of 10 users per minute. The second bucket is, let's see what the endurance of our web server is. So we set up a fixed user load of 20 users and we leave the server running for 3 days. And remember that IIS tends to restart by default after 17-20 minutes. So you can test how your application will behave once the IIS has restarted, or what error messages can the user run into once the IIS has restarted. Over here, I can choose to set the validation levels to low or high, and basically press finish here. Once I click finish, from the wizard, I have this test run settings file generated. I can choose to add counters. So if I wanted to see what the CPU utilization is, or how much of memory was used, and other perfmon counters, I can add them from here. And the beauty is that Microsoft has already set up these perfmon counters with threshold limits. So you don't have to go and look at data and think, well, is this high or is this low? If the recommended threshold count is violated, then the test already notifies you saying that, we possibly have a warning. And if it's entirely breached, you get an error message saying that, boss, your test will really destroy the web server. At this point, I'll show you that how I can access my test rig that I've set up in the cloud. I click on the Manage Test Controller button. At present, it's saying, local. But if I go off to my Windows Azure portal, I should be able to see the test controller machine name. So let's go off to the management portal here. And this is the test controller machine name. I can copy this name and go back to my virtual machine. Click here, click paste, tab out, and it's trying to contact my test controller setup in the cloud. First time it does tend to take a minute or two. Bear with me, please. Brilliant. So I can see that my test controller has been resolved. It can further see that I have 2 test agents associated with the controller. You can click here to see the actual connection string in the test controller, and it will show you that the test controller is using the load test database, which is also set up on the test controller. And I can test the connection here. Again, since doing this for the first time on this virtual machine, it does tend to take a minute or two when you do it the first time. Brilliant. So the test connection succeeded. So look at the beauty. From my machine on premise, I'm able to establish communication using Windows Azure endpoint to the test rig that is set up in the cloud. Okay, press OK. And press close here. Now I think I'm ready to start testing my so I'm just going to click run load test. Now what this does is it does a quick compilation, and it started to progress my test. And the beauty is that it gives you a real-time test execution metric as well. I can see that the test has started executing, and it will show me the user load or the IS request response, some of the perfmon counters right here on the screen. Now, what I'll do is I'll leave the test running for 10 minutes to let it collect some rich data. And meanwhile, I'll show you 2 cool things that you can do in your own organization to automate the creation of web performance tests. Okay, so recently I did a blog post on how you can use the IS logs for performance testing with Visual Studio. Now, if you're running if you have your web server using IIS7, then you're probably aware that the IS logs get created in the directory C interpub logs. And the IS logs capture all the requests and the response that the IS server receives. Now, the beauty is that you can use the log file that gets created and create the web performance test by making use of the Visual Studio Web Performance Test API. Now, if I show you the solution for that, you'd say, well, it was so simple. Why didn't I do this before? How it works is I'll be making use of the IS logs and a tool that is free, which is known as a free tool which is known as log parser. Now, log parser is a fairly good tool. What it does is, now let me give you a quick look of what an IS log looks like. So this is an IS log. It records when the request was made, whether it was a GET request or a post, what port, what was my web request, and it even shows me the HTTP code for the request, whether it was a success, a failure, so on and so forth. You know, if you look through this from a human eye, it's fairly difficult to translate what is in here. But what's good is if you make use of the IS log parser, then it gives you a way to query this IS log programmatically. And this is what I've done. So all that it does is says go off and query the IS log, get the SIP, get the S port, get the method, get the URI, and get the query. And once you get that, if it's a GET request, just transform these into a URL and add that URL as a request. And once the request is captured, then simply return that request. So all you have to do is specify where your IS log file is kept, and it goes off to the IS log and goes through this entire process of extracting all the web requests and then transforming those requests into proper URLs, and then comes back and says, okay, you know, from that IS log I have a request, and that can become my web test. Now the good thing is, because you have all these additional fields in your IS log, such as you know, what the authentication code is, or how many bytes were transmitted over the wire, you can actually figure out how the application is being used in production. What are the most heaviest pages, or what are the most frequently tested pages? Sorry, what are the most frequently used pages? And then you can base your testing off of that. If your application is production, you don't have to waste time anymore to figure out which are the hot pages I should be testing. Instead, looking at the IS log, you already know which are the pages which are always in demand and should perform better. And using this technique, you can auto-generate the test for all those pages. There's another way to test this, which is using Fiddler. A colleague of mine who's also an ALM Ranger has posted a blog post on how to do that, which I'll show you shortly. Here we go. So in his blog post, he's shown that if you bring up Fiddler, if you install Fiddler, in case you haven't used Fiddler, it's a web proxy tool which lets you record all the requests and the response that take place between your web server and your client. Now, once you've recorded, once it's captured this, you can simply choose File, Export Session. You can either choose to export all the requests or the selected request. And once you do that, it gives you an option to say, where do you want to export it? You can choose Visual Studio Web Test, and next thing, it's already generated a web test for you. So, these are nifty techniques to, we're saying, let's take this to the next level by making use of Azure, getting rid of the problems we have in scaling. And on the other side, we're looking at techniques that help us speed up putting together those tests. And if you take both these approaches in parallel, you can not only scale up your test, but quickly bring more tests and test those tests. So you understand what I mean, right? Now let's go back to the session we were running on the VM. So I can already see that 6 minutes of test execution has taken place in the test rig, and oh boy, is the website under some sort of pressure. I can see that my website has produced around 1,218 errors. And that's purely because the website that I'm testing today was never built for such a large user load, right? It was just built for an intranet event information where we're telling a small audience of 200 people what the event is about, and they can register. And today I'm testing that website for 20,000 users. Probably the IS has maxed out itself. Probably it's not able to serve any further requests or produce any other responses. So, interesting figures here. So if I drill down into some of the errors, and this is the test I'm running, right? Viral load test, web test. I can see the page. I can see this is the home page. So I can see that this page, on an average, the minimum time it took to render this page was 0.17 seconds, and the maximum time it took to render this page was 39 seconds. The last time this page was called to a test, it took 20 seconds. So, you're being able to see the test results in real time. And, if you start making sense of the numbers, it's fairly easy to see that as the user load is increasing on the page, it's taking longer for the web server to load my page. And then, once the test finishes, you get finer details of what page took the longest, and where were the bottlenecks, and so on and so forth. So I think we have run the test enough. I will stop it for the purposes of keeping the looking at time constraints we have for the demo. So once I stop it, it's just analyzing all the test results in the background. It's going through the test results to see make sense of it. And once the analysis is complete, it will take me to a summary page. A summary page is an eagle's view of how my test went. So see, it's reading all the counters from the database. It tells me that I ran the test for 7.27, 95% of my test. The sponsors page took 84 seconds. Now imagine if you were a user, you would have abandoned that website were you made to wait for that longer. I could only generate a maximum user load of 890 users, and each test completed in about 3 seconds. 500 of my tests failed, probably because the web server couldn't respond because it was overburdened, and each request took around 57 seconds. So you see, I'm coming to the point that it's fairly easy to see from the summary page how your test is doing, how your website is doing, and you can also get a glimpse of what the exceptions were. So I can see that there was an HTTP error. I started getting an HTTP internal error, which means my server was knocked out, my web server. And because I was putting additional load after every 10 seconds of 20 users, the server might have perceived that as a DOS. Which means fearing that this is some sort of attack on the web server, so it might have shut the connection down. So I'm getting a socket exception as well. So in summary, it's fairly easy, as we saw today, to set up a test rig in the cloud. It's simple, it's efficient, it's cheap, it's got great ROI. It's even simpler to use techniques such as using Fiddler or using iOS logs to put together web tests, and then just taking those web tests, putting them on the test rig, executing them, taking the results. And I imagine when you start building your website, inculcating these practices from the very beginning, by the time you reach the end of your development, you have sort of already performance tested the smaller units of your application, which makes testing the bigger application as such much simpler. That was for the demo. I'll take you back to a few of the presentation slides I have left now. Okay. The next slide is concerns, cost, and practical scenarios. So now that we have covered the why and the how, I've taken this solution to many clients we work with, and usually at this point on the slide, they've started embracing the approach, and they probably come out with more direct questions around, okay, if I enroll for this, what are my cost prospects? How much am I going to be charged for running my test rig? Is this even practical? What kind of websites can I test with this? And sometimes they come back with concerns on security and so on and so forth. So let's try and address the cost aspect of it first. So I'm gonna try and speak from prospect of some numbers here. If I was to set up a large Azure instance, a large Azure instance costs me just about $0.48 per hour. So if you have one controller and 3 agents, we're looking at 4 machines, 4 large instances of Windows Azure to run for 3 hours of testing. Now that 3 hours could include the setup, the test execution, and the teardown. The cost will only come to around $5.76 for those 4 machines of large instances hosted in the cloud running your test. Not even $6 for 3 hours. That's amazing. Compare that with buying a new server. Is there a comparison even possible? Not in my opinion. If you were to run this setup of 4 machines for an entire day, you will only incur a cost of $47. And if you crunch the numbers, for every additional large instance that you add on top of this test rig, you will only incur $12 a day. Imagine just $12 for an additional machine. Whereas if you were to go off to your infrastructure team and ask for your machine, you would be told to get approvals because the hardware is very expensive when you set it up on your premise. So the point I'm trying to make here is you are charged for your usage and you're not charged for buying the hardware. There will be an additional cost for running the test. So every time you come out from the data center, you would be charged. And that cost can really be calculated by looking at the test size, the number of request response it generates, and how many times do you practically come out of the data center. And you could be clever here. You can start storing both your website and the test agents on the same Azure data center, so you don't practically come out from the data center, so you don't really incur a cost. Some of the practical scenarios where this could be tested, this is a perfect fit for energy trading companies, for global finance companies or banking companies or stock exchange companies, which expect large amounts of data for their application. Large volumes of data needs to be tested with the correct mechanics which are available in Azure only. This is a great fit for global applications which are not hosted locally but spread across the globe. And some of the concerns that I've heard in the past are more around data security. Well, Well, we're using Windows Azure endpoint, which creates a tunnel, right? And all the communication is secure within the tunnel. But if that kind of stops you, then you can always go down the route of setting up your private cloud, like setting up your own data center and then taking this setup in your own data center. Now, I've already demonstrated to you how we can use the IIS logs to automate the creation of our web performance tests. And with this, I'd like to recap by saying that we covered why there are problems in the conventional approach, how Azure lets us fill the gaps. We addressed some of the costs and concerns. We walked through the test rig setup, doing a test execution, setting up a load test, taking the results, looking at the results, and then looking at ways to automate the web test creation process as well. So these are some of the resources that I used for putting together my presentation. And I'm happy to take up any questions that you may have now. I'd just like to highlight and then finish the session by saying that, we're very agile now, and it's high time that we start cloudifying those tests of ours as well. So if you have any questions, then please route through your questions or unmute yourself, and I'd be happy to answer any questions that you may have at this point. And I'll also encourage you to take this poll that I'm putting up on your screens now. So what will you take away from this session? Would you like to try out leveraging Windows Azure for performance testing? Or do you think that this is not practical at all? Or you think it's practical, but you still have some questions?